Here's a mathematical computation that is defined iteratively, and that makes it very natural to define it as a recursive function. The factorial of a number n is just n times the factorial of the smaller number until you get down to a predefined number that has a factorial known and where the factorial of 1 is defined to be 1. We're taking this function factorial and we're calling it again within itself with slightly different parameters. And we need to make sure that there's somewhere along the way, some kind of test where we no longer call the function recursively. So that's kind of like our if we were modeling this as a loop, this is how we would like break out of the loop. But in recursion, we just return from the function without doing more recursion. Let's look at this visually. Here we're going to take factorial of 3. That's going to return 3 times whatever the factorial of 2 is. And when we call factorial of 2, we actually are back in the same function, but now entirely different data. So now we're going to say, well, factorial of 2 is going to be defined to be 2 times factorial of 1, and we're going to pass 1 down. But remember, the factorial of 1 is just 1. And as we work our way back, we pass 1 up, we do 2 times 1, and that's 2. And we pass the 2 back, and we say 3 times 2, and that is 6, which gives us our answer. This is one of the core concepts of computer science and computer programming. It's not used super often, but when it is used, it's so perfectly aligns with the types of problems you're solving. If you're dealing with hierarchical data structures or you're dealing with these iteratively defined algorithms, recursion may be what you need.